Hi guys, welcome to our channel. Today's topic is understanding model step size and block sample time. In model configuration settings, we can change different model simulation parameters like simulation type, solver selection, and solver details. Today's point of interest will be fixed step size, that is fundamental sample time for model. Sample time specified in this particular section will be inherited by all the blocks present in model. Unless sample time settings are specified, all the blocks will be executed with the sample time specified here. By default setting is auto. Let's see what that means. To understand model step size and block sample time better, I am considering sine wave block and free running counter. A sine wave block will provide us a sine wave with amplitude 1 with frequency of 1 second and sample time is 0. At the same time, free running counter will count for 4 bits, that is, it will count till 16 with sample time as -1. I have created a logic which can provide us number of steps executed and a calculated sample time. Also, we are using a clock to display simulation time. Let's simulate this model with stop time equal to 10. Remember, we have selected fixed step size as auto. When we complete simulation, we can see our simulation time is 10 seconds and Matlab has executed 50 samples at sample time of 0.2. Let's see what is a waveform of sine wave generator. We can see smooth sine wave on a scope, and at the same time counter is counting till 15 and then resetting. Also, the output from delay block is following a counter with 1 step delay. Now let's simulate the same model with stop time equal to 20 and see the result. So when stop time is equal to 20, the number of steps executed is still remaining same. However, the sample time has changed to 0.4. Since we are sampling with higher rate, we can see the sine wave is little distorted than earlier, and the counter is counting till 16 with step size of 0.4, and the output of delay block is still following counts by delayed by 1 sample time. Now let's try executing the same model with sample time of 40. With sample time of 40, again the step counts are still remaining as 50. Now the sample time has changed to 0.8. The question here is how Matlab is changing its sample time whenever we are changing the stop time. When we simulate a Simulink model with fixed stop time and step size as auto, Simulink model will execute for 50 steps. So the step size will be calculated as stop time minus start time divided by 50. You may want to go back and check if this particular rule is applied for our simulation. Let's see what will be the step size for stop time as infinity. When we simulate model with infinite stop time, at that time Simulink will select its sample time as 0.2 seconds. This is a default setting for Simulink model. For all this simulation, the sample time for individual block was inherited from a model step size. Now let's try changing sample time of free running counter 0.3 seconds. When we simulate this model, we can see that Simulink has selected sample time for entire model as 0.3 seconds. This is because one of the block has been specified a fixed sample time, and that particular sample time is now applied to all the blocks. Let's apply sample time of 0.4 seconds to unit delay block. When we simulate this model, we will see a sample time of 0.1 second is applied to complete model. When different sample times are provided to different blocks, then its maximum common divisor will be selected as sample time. So for 0.3 and 0.4, maximum common divisor is 0.1. Now this block is executing at 0.3 second and a unit delay block is executing at 0.4 second. If we see outputs in scope, we can see that counter is incrementing at 0.3 seconds and output of delay block is being updated at 0.4 seconds. Now let's change the sample time of pre-running counter to 0.8 seconds and sample time for unit delay block as 1.2 seconds. And when we simulate this model, we will see that new sample time of model is coming at 0.4 seconds, which is the maximum divisor for 0.8 seconds and 1.2 seconds. Now the counter block is being executed at 0.8 seconds and unit delay block is executed at 1.2 seconds. We can verify the same thing in the scope. So you can see that counter is incrementing at 0.8 seconds and the delayed output is being updated after 1.2 seconds, even though the complete model is being simulated at 0.4 seconds. Now let's try specifying fixed step size for complete model configuration settings. We'll specify fixed step size at 0.2 and see what is the result. Now if we simulate this model with stop time equal to 10, we are getting sample time as 0.2. If we simulate this model with stop time of 20, we sample time as 0.2. So irrespective of stop time, our Simulink model will be executing at sample time of 0.2. Now if we want to change a sample time of individual blocks, then this sample time should be in multiple of the fundamental sample time we have mentioned in configuration settings. That is, for 0.2 second sample time, the sample time for individual block should be in multiple of 0.2, that is 0.2, 0.4, 0.6. If we specify anything apart from that, let's try specifying as 0.1. Then Matlab will throw error stating invalid setting for fixed step size, and all sample time in model must be an integer multiple of fixed step size. Let's try providing sample time for pre-running counter block as 0.4 seconds and simulate the model. So here you can see that both delay block and counter block are executing at sample time of 0.4 seconds. So even though the sample time specified for unit delay block is -1, because of its input being executed at 0.4 seconds, unit delay block has inherited its sample time at 0.4 seconds. All other blocks are executing at 0.2 seconds. Thanks for watching this video. Please provide your feedback in the comment section. Please subscribe for more videos on simulation.